the derivative sketches in velocity and other rates of change. So sketches of derivatives are a little bit tricky. We did a little bit the other day when we talked about sine and cosine. So I want you guys to think about what the number is for the slope. Like if I was giving a numerical value to the slope at this point, what would the numerical value be? Okay. So really all we're going to worry about is when it's positive and when it's negative. All right, so the first thing that I had you guys do when we talked about sine and cosine is we found where we had horizontal tangents. So we have a horizontal tangent here, 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 and there is one more location. Do you guys see it? Where?
There.
Right there at 2, right? So sometimes it helps if you kind of do like a little number line, and you're like, okay, at -3 I hit 0, at -1 I hit 0, at 2 I had a slope of 0, and at 4 I have a slope of 0. And then we're just worried about whether our slope is positive or if it's negative. Okay, so as I'm going from the left to right, so from -infinity to -3, my line is going downwards, correct? So that's a negative slope. So right here we have a negative slope. So I'm just going to put a little negative there. So I know that if I had numbers associated with the slope, they would be negative numbers. All right, you can really like split hairs, that's the saying. Like you can try to figure out where the most positive or the biggest negative slope is and the smallest negative slope is. But I don't really worry about that too much. I just worry that it's negative. Really, like, it's super steep up here, and it has to taper off in order to go to a slope of 0. So the negative slopes are getting smaller. All right, so the next little bit from here to here, is the slope going to be positive or is it going to be negative?
Positive.
It's positive because we go upwards, right? So all numbers associated with that are going to be positive numbers for slope. And then we have negative, so it's going downwards, and then it's going downwards again. So it goes downwards, super steep for a second, then it tapers off to a slope of 0, and then it goes downwards super steep, right? And then it's positive. Okay, so if I'm doing a sketch of the derivative, maybe I'll do it separately. You guys can put it on top of the graph, but maybe I'll separate it. And I'm thinking about all these numbers. At -3 I have 0, at -1 I have 0, at 2 I have 0, and at 4 I have a slope of 0. My numbers are negative, then they're positive, they're negative, they go to 0, they're negative again, and then they're positive numbers. Do you guys see it? Negative numbers, positive numbers, negative numbers, negative numbers, positive numbers. So I'm not talking about the slope anymore. I'm talking about the numerical values for those slopes. Do you guys get that? It's kind of weird. I didn't like this when I was in school. I always had a hard time with it. Okay, so if you graphed it right on top of this graph, you would have, you first draw in your zeros, and then you're like, okay, I have a negative slope, so my numbers are going to be negative below the axis. Then I have positive, negative, negative again, and then positive. Okay, so that would be a rough sketch of the slope. Okay, did you guys get that? Okay. So some basic examples, and again, you don't have to write these. Let's think about derivatives that we know. If we had y equals x squared, what's its derivative? Yeah, it's 2x, right? So if I draw my 0 slope first, I'm like, okay, the slope's going to have 0 there. And then my slope is negative, and then it's positive. So I'm below the axis, and then I'm above the axis. Do you guys see how that makes y equals 2x? Y equals mx plus b. It's a straight line. Or if you guys had y equals x cubed, it tapers off to a slope of 0, right? So we have a slope of 0, and then we have, it's a positive slope, and then it's a positive again. So it's above the axis again. Does that make sense? Y prime is equal to 3x squared. It's a parabola. Do you guys see it? How it's related? All right. So let's do this one. So if I was trying to do as quickly as possible without doing like the number line and so on, I would first find where my slopes are equal to 0. So there are 4 locations. So I draw those along the x-axis. And then I decide where my slope is positive and where it's negative. So I have a positive slope, then I have a negative slope, a positive slope, a negative slope, and then a positive slope. see it? So that means we're going to be above the axis, below the axis, above the axis, below the axis, above the axis. That would be the derivative. Do you guys understand that? Okay, the big mistake that people will do is they think about the slope of the slope. And they're like, wait, but this was going up. That was increasing. So why am I starting the graph and I'm going downwards? Right, do you guys understand what I'm saying? So think of the numerical value of the slope. It's positive, so when you graph it, it's above the axis. It's like doing a big T-table. Good? Cyro, are you good? Cyro's like this. All right. Okay, so that's the first thing. So we're not going to waste a lot of time graphing the derivative. I think you guys will understand that as we go through the semester and so on. You'll do more and more of that. Okay, so in physics, how many of you guys have taken physics before? Raise your hand.
Does that include taking it right now?
Maybe about half of you. Sure, it includes taking it right now. Okay, so you guys know position, velocity, acceleration, right? Those are all related. Okay, so the position or displacement function, so I might call it the position function, but same thing. It's going to have units like meters and feet, inches, some kind of distance, okay? But when you take the derivative, you're finding the rate of change. So this is going to be like that unit, like meters per some amount of time. So meters per second, feet per second, miles per hour, right? Those are going to be velocity. And then the derivative of that is going to be units like meters per second, which is meters per second squared. So the original starts out with meters. The derivative is a rate, meters per second, right, a slope. And then the last one is like meters per second, which is the same as meters per second squared. So we're going to have our original, the derivative, the second derivative. Okay? So if you start with the displacement function, s of t, then s prime of t is the velocity, and s double prime of t is the acceleration. So if you ever see the AP test ask for speed, so this is another thing that might come up. Do you guys know the difference between speed and velocity? Velocity has direction. So if I'm standing in a straight line and I'm like, okay, I'm going to go -5 miles per hour, then that's telling me that I'm going backwards. Okay, so I'm going to go backwards -5 miles per hour. But if I just have the speed, then I would be going 5 miles per hour. Okay.
Velocity can have positive or negative, basically.
Yes, velocity can be positive or negative. Speed is always the absolute value of the velocity. So absolute value of velocity. All right, so number 1 says the equation of motion, in other words, the position of the particle, is s equals t cubed minus 3t, where s is in meters and t is in seconds. So right now, our function is in meters. It's some kind of position or displacement, right? So find the velocity and acceleration as functions of t. So if I'm finding the velocity function, it is going to be the first derivative of our position function. So I take my position function and I take the derivative. So I do 3t squared minus 3. And then my acceleration function is going to be the derivative of that. So it's going to be the second derivative of the position, which is 6t. So once you have those, you can ask any question about those. You could say things like, find the acceleration after 2 seconds. So your acceleration after 2 seconds, you would plug in 2, and you'd get 6 times 2, which is 12. All right, be careful to write your meters per second squared, and so on. Velocity is in meters per second. Acceleration is in meters per second squared. Okay, I don't know why I wrote out meters. All right, so acceleration is going to be meters per second squared. So on the AP test, if you guys do not write your units, you often will not get the point for the answer. Okay. As Mr. Crowley says, units are the key to life, right? Doesn't he always say that?
No.
All right, okay, maybe not. All right, so the acceleration when the velocity is equal to 0. So first we want to know, when is the velocity equal to 0? So we're solving. So v of t equals 0. V of t was the 3t squared minus 3. We set it equal to 0. Can you guys do this in your head? Not 0. T equals plus or minus 1. Can you go backwards in time?
Yes.
No. This isn't Back to the Future. So time, so we're going to say t equals 1 second. So this happens, the velocity is equal to 0 at 1 second. So if I'm finding my acceleration at 1 second, then I'm plugging into the 6 times t. So I'm going to have 6 times 1, which is 6. So that's going to be meters per second squared. Okay, so I used one answer to find the next answer. Easy enough. It's really not that bad. All right. So do you guys know Mr. Crawley and I went to the same high school? I told you that before, right? Muncie Central Bearcats. There is something called a bearcat. You can look it up. It's a funny-looking animal. We were not the same year. So we often compare teachers, and we're like, oh, yeah, I had that teacher, blah, 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 you know. And he's always like, oh, yeah, I loved my calc teacher. He was awesome. And I was like, I feel like I liked the guy. But, like, when I went into that test, it was like, whoa. It was, like, not what I thought it was going to be. And so years later, you know, as I'm going to all these AP conferences and stuff, I learned that 1998 was when they changed the test completely. So Crawley, his test was very much like the last one, like where you have a function, you take the derivative, you might take the second derivative, you're plugging things in, and so on. And then in 1998, they just had all these like graphs, and they had all these like tables that you have to solve, like use to solve things. And my teacher like never did any of that. So he was a very nice guy, but he changed. So Crawley had graduated in 97, and I graduated in 2001. And our experiences in calculus were very different because of that. Interesting, huh? All right, so anyway, so we have questions like this on the AP test all of the time. You will have at least one graphing question as a free response question. So it says, use the graph to answer the question. So at what time t is the unicycle stopped? So if you are stopped, notice we have velocity, and this is in minutes, time. So our velocity has to equal 0 if we're going to be stopped, right? So we're saying, where on the graph is our velocity equal to 0? And there are 3 locations. So our unicycle is stopped at time 0 minutes, 30 minutes, and I want to say 60, but it's not, 55 minutes. That is where our unicycle is stopped. Side note, so we have talent shows every now and then. In the talent, you know, there's some pretty good people and so on. But the best talent show we ever had, I'm still in shock. It was at university, yes. The best one we ever had was Maddie Hoover's older brother, JD. And he can ride a unicycle while juggling fire. Like, it's the most amazing thing I ever seen. So then, you know, other people come up and they sing a song, and you're like, oh, that song's pretty good. But yeah, I mean, he just rode a unicycle and juggled fire. It was amazing. I've never seen anything like it. Yeah, so if, you know, at university, if we actually had trophies for such things, I think we would have won it. All right. Anyway, it's Grant saying something funny. All right, so when is the unicycle going backwards? So what do we think? When is it going backwards? Yeah, between 30 and 55 minutes, right? So you could say on the interval 0 to 30, but I would probably want to put units. So I'm going to say between 30 and 55 minutes.
If we put 30 minutes to 50 minutes to count that, we're thinking with that
That's fine.
30 minus 50.
I think you're fine. All right, so what is the acceleration at 30 minutes? So how is acceleration related to velocity? Acceleration is the derivative of the velocity, right? So we want the derivative of velocity, but we don't have a function that we can take the derivative of. So derivative is the slope, right? A derivative is slope. So I want to find the slope at 30 minutes. So I want to find the slope of this line right here. And we can count. Now, some people will count and they'll be like, okay, I go down 1, right 1, down 1, right 1. My slope is -1. All right, but you're going to be smarter than that. It's not -1 because look at your grids. Jordan was like, oh, I did that. What am I going down by? 20. What am I going right by? 5. So it's actually -20 over 5, which is -4. So it's -4 meters per second squared. So be careful.
Meters per minute squared.
Ah, dang, minutes squared. Thank you. I did that earlier too. When you take a lot of physics, you always do like meters per second squared, and so on. All right. What is the speed at 35 minutes? So what's speed? Absolute value of velocity. So the absolute value of the velocity. So we're finding the velocity at 35 minutes, and then we're going to make it positive. So if it's negative, make it positive. So at 35 minutes, we are right here on our graph. Our velocity is negative 20. So we're going to say negative 20, but then it's in absolute values. So it's 20, and our units are just like velocity, meters per minute. I'm going to keep doing that. You're about to get me.
Why don't you just put meters per second for the problem?
I know. Wouldn't that be nice?
And you wouldn't have to give out bonus points.
All right. When is the acceleration the greatest? So when is the acceleration the greatest? So acceleration is the derivative of velocity. So we're asking the biggest slope on the graph. Yep, it's from 0 to 10 minutes. I know, see? Happens to the best of us, right? Okay, so you can look at it. In this slope here, you go up 60 over 10, so that's 6. So the slope here is 6. You can see those other ones are not anywhere close, right? This is going up a certain amount and over a certain amount. It's not the same. It's up 40 over 15. That's not as big as the other one. All right, do we feel pretty good about that? No, we're not playing good. All right, I messed up my grid lines. Okay, next up. So it says when you're driving a car, the speed or velocity is constantly changing. Okay, there's a definite velocity for each moment, which we refer to as the instantaneous velocity. So let's say that you go 150 miles, and it takes you 3 hours to get somewhere. What's your average velocity? 50 miles per hour, right? Does that make sense? You guys get it? Do you launch yourself out of your garage at 50 miles per hour and stay at 50 miles per hour until you get to your location?
Probably not, because then you'll crash into the house on the opposite side of the street.
Right. We do not do that. Okay. We probably stop at stop signs and go a little bit faster in various places. All right. So the average velocity is like between one endpoint and another endpoint. Like at the start and the finish, find the slope, right? So we're finding our position function, S of B minus S of A, all over B minus A. So S is in, units like meters, feet, etc. And then B minus A, these are our time. So this is like seconds, minutes, etc. So in the end, we get meters per second. Or feet per minute, whatever. All right, but the instantaneous velocity is the exact slope at a particular point. So it says the limiting value. Well, how do we get slopes? We found the limit as h went to 0, right? So the limiting value of average velocity is at a particular time. So in other words, it's the derivative. I'm misspelling it. Derivative of the position function at a particular point. Okay, so if I ask for the average velocity, then you're finding between two endpoints. But if I say, what is the velocity at this exact time? At t equals 2, at t equals 3, whatever, then you do the derivative.
S prime B minus S prime B?
Nope, it's S of B. Yeah.
No, for the instantaneous.
It's not subtracting, it's just S prime of whatever. S prime of whatever your value is. So not an endpoint, but like S prime of 2 would be an example. All right, so this is very important on the AP test. So if you ask for the average rate of change of anything, it's F of B minus F of A all over B minus A. You've all memorized that formula, right? It's the slope formula. But if you say instantaneous rate of change, then it's F prime of X. So at a particular X value, or F prime of A. So number 1, it says if a ball is thrown into the air with a velocity of 40 feet per second, its height t seconds later is given by y equals 40t minus 16t squared. So you guys have seen these in every single math book. Right? You've seen these types of equations. It comes from calculus. It has to do with gravity and so on. So find the average velocity for the time period beginning when t equals 2 and lasting for 0.5 seconds, 0.1 seconds, 0.01 seconds. Okay, so we're finding the average velocity, average rate of change of the position function, right? So we want to find, let's go ahead and plug this in for y1 on our calculator so we can find lots of values as we go. Yeah, because if you find a whole bunch of like, why of this, you might as well put it in. Okay, and then yours is already set for this, but if you ever have to change it, you can go to table set and make it so you have ask and then do table. And now you can put in whatever you want. So when we say it lasts 0.5 seconds, that means we want to find the point at 2 comma something and the point at 2.5 comma something, right? So we want to find the height at each of those locations. So we can plug into our table. So we're going to plug in 2 and we're going to plug in 2.5. So we get 2 comma 16 and we get 2 comma 0 or 2.5 comma 0. So when we find our slope between those two, it's going to be 16 minus 0 over 2 minus 2.5. We get negative 32. Units? Nope. Feet per second? It's average velocity, yes, so feet per second. All right, so if I go between 2 and 2.1, I still have my 2 comma 16, but now I need to find what 2.1 is. So you can go and you can plug into the table or just plug it into your calculator just like normal, 13.44. I know that that's exact. I can go over. Do you guys see how you can see more digits when you go over? Still just 13.44. So I have 13.44. So when I find this one, 16 minus 13.44 all over 2.1 minus 2. Anybody have it? Negative 25.6 what? I did this way. 16 minus that. Oh, yeah, you're right. Dang it.
And then on the other one, it should be 0 minus 16. And then
Nah, I'm good on that one. I did 16 minus, and then I did that one. So I'm good there. It should be negative in the end. All right, so what did we get? You gonna make me do all this? What was it? Ian, what did you have?
Yeah. For which one's
For B, yes.
Negative 25.6 feet per second.
Negative 25.6, and that came out nice and even like that?
Yeah.
All right, thank you.
Sorry, I caught you.
All right, you were busy doing the next one, I know. So 2 comma 16 and 2.01 comma, you can find that as well, 2.01. So 15.758, but if you go over, you actually get more digits. So 15.758.4.
They
So-
would not put anything like this on the non-calculator portion, would they?
No.
Okay.
What do we get? Negative 24 point something. 16, is that right? I don't know. You guys can figure it out. I think that's what it is, but that's just me memorizing numbers. All right, so it says estimate the instantaneous velocity when t equals 2. So we're getting closer and closer to getting the slope at an exact, like at a single point, right? We're doing that limiting values thing. So we're taking them and we're scooching them closer and closer. So it looks like it's going to be pretty close to negative 24. So my guess is going to be approximately negative 24 feet per second. But if I actually want to find it, if I asked, what is the instantaneous velocity at time t equals 2? Then I take my original and I take the derivative. So this was my height function or my position function. And I take the derivative, so I have 40 minus 32t. So when I plug in my time 2, I do get negative 24. So negative 24 feet per second. Are they doing jumping jacks? It's really random. All right. And then E says, when is the velocity equal to 30 feet per second? So we're finding when our velocity is equal to 30 feet per second. So we're going to have, our velocity was the one up here, v of t equals y prime. So we're going to have 30 is equal to 40 minus 32t, and then we solve it out. So subtract your 40 over. So 10 over 32, which is 0.3125 seconds. All right, now the AP test, this was an exact answer. Like, it came out exactly to 4 decimals. So you can write your exact answer. You could write it as a fraction, which is 5 over 16. That would be accepted. Or you can truncate. So you can say 0.312, or you can round, 0.313.
So all three of those.
Any of those. to work. But if it's a rounded number, I wouldn't write out all the decimals that your calculator gives you. I would just round to 3. Okay?
Can you truncate on this?
You can truncate, yes. All right, so that's position, velocity, acceleration. Do we feel pretty good about those things? Jordan, you with me? Do we feel good about those things? All right, can we do some econ stuff?
What?
I was hoping to wait till
Yeah.
February to do
How
that.
did it switch from
All right.
physics to econ?
You know, that's just what I do.
I thought this was like a year later.
Yeah. So how many of you guys are in econ right now?
No.
How'd you guys do on that first test? She's
Cyro's like,
oh,
I
Cyro
failed
got an
camera.
egg.
I remember yesterday at the match.
She's a tough grader.
Yesterday at the match, Eric and Luke were, when they weren't playing, they're like, okay, gotta study econ. Eric was joking, like,
I
I should
know.
bring my econ book on and play with one hand and study with their
I
hands.
know,
like,
it's
freaking out.
difficult. All right, here we go. So in economics, the word marginal is used whenever you talk about a rate. So if you talk about the marginal profit, it's basically like your profit per item, right? So marginal. Yeah. It's been a long time since I took
Also,
econ.
our
All right. Marginal cost is the derivative of the cost function. Marginal profit is the derivative of the profit function. So marginal, anytime you see marginal, you are taking the derivative, okay? So nowadays, new efficient machines allow the cost of a product to not be constant. So I gave an example. My aunt makes necklaces. She goes to little art fairs all over the state and sells necklaces, okay?
Was she
So
at the
maybe it costs her like $10 to make a necklace, maybe, right? But then she sells it for $35.
Whoa.
So she's making a profit of $25 per necklace, right? Yeah, I don't know. So it takes her a long time to make them, though, and so on. So, but she spends a lot of her time making these necklaces. So she could decide, hey, my business is really growing. I want to make a whole bunch of necklaces all at once, and I'm going to buy this machine that helps put the beads on the string or whatever. Okay. But if she buys this machine and the machine costs $10,000, but then she goes to these different art fairs around and she doesn't make $10,000 a year. Maybe she only makes like $2,000 over the year. That's not very good, but let's say she only makes $2,000. Would she waste $10,000 on this machine? Probably not, unless she really plans on making necklaces for the next 5 years at least. Okay? So do you guys understand? Like, there's benefits to purchasing machines to make the cost not as much. But sometimes when you purchase a machine, then that makes your cost very, very expensive. All right. So basically it just depends on the payout. So how much are you making per necklace and so on. If you're making more necklaces, is it worth it in the end? So besides marginal cost, you could see many other terms about the cost function in econ. So average cost is exactly what you think it is. So what do you guys think average cost would be? Adding all of the costs together and dividing by the number of items you produce, right? So maybe it costs her $10 for one necklace, $15 for another, $3 for the next. You add them all together and divide by the number that she made. Okay? Yeah. So the average cost is written as C bar. That's what we call it, C bar. It's C of X with a line over it.
I see.
It's read as bar. And what it is C of X divided by X. So it's the total cost divided by the number of items. So we're going to keep it simple. Think back to when you were a kid. Did you guys ever do a lemonade stand? Back in the day. I was quite impressed with some young entrepreneurs. I passed by what's that elementary school over there? Next to the BMW Classic the other day, the golf championship. Yeah, so I passed by the elementary school, and there's little kids out there with their little lemonade stand selling some lemonade, and I was like, they are making a lot of money. That is some smart little kids. So
I saw this one kid offering car parking for $75.
yes, I did see that as well. So think about the first time that you made money. So back in the day, a lemonade stand. My brother and I always had these. Suppose you go to the store and you buy 6 of these classic tubs of Country Time lemonade. That was my favorite. And they cost $1.50 each. If you bought 6 of them and they cost $1.50 each, how much money did you spend?
$9.
$9. 6 times $1.50. So with each container, you are able to make 60 cups of lemonade, which then you sell for 50 cents each. You're a nice kid. You're selling it for 50 cents each instead of $1. A lot of the kids are selling for $1 each. All right, so how much are you making? Not 30. Be careful. You have 6 containers. 6 containers, 60 cups each. That's 360 cups of lemonade that you're selling for 50 cents each. You made a total of $180 if you sold all of it. However, this really isn't your profit because originally you went and you bought that lemonade or the supplies or whatever. So when you bought those containers of lemonade, you have to subtract it out. So you have 180 minus 9, you'd make a total of $171. Pretty good for a little kid.
Even in general, it's not bad.
So revenue is the amount of money that you brought in. So at the lemonade stand, it's the amount of money that's in the jar at the end of the day. Okay? This does not include the cost of purchasing the lemonade or making the item. So therefore, your profit is equal to your revenue minus your cost. Okay, does that make sense? Revenue, cost, profit. All right, so let's do an example. So it says the cost of producing X units of a certain item is C of X equals 1/4 X squared plus 3X plus 67. The price at which each item will be sold is P of X equals 1/5 of 45 minus X. Suppose we sell all X items. So find the marginal cost. So if you're finding the marginal cost, remember I said marginal is derivative. So you're going to have C prime of X. So when we take the derivative, I get 1/2 of X plus 3. So I took the derivative of this cost function. 2/4, right? 1/2. Average cost, that's your C bar. It's your total cost divided by X. So we're going to take our 1/4 X squared plus 3X plus 67 over X.
4x plus 3 plus 67 over x.
So 1/4 X plus 3 plus 67 over X is our C bar, or our average cost, C bar. Easy enough. Revenue. Revenue is the total amount of money you're taking in. Now, I didn't tell you the total revenue, right? I told you the price per item. So let's think about it. If the price per item was $10 and I sold 50 items, I'd make $500. Does that make sense? That would be my revenue. So we're going to take our number of items, X, and we're going to multiply by the P of X, the price per item. So it's X times 1/5, 45 minus X. So we did number times the price per item. And we'll go ahead and simplify. So we get X over 5 times 45. So 9X minus 1/5 X squared. Did I make a mistake?
Isn't it 45 minus X?
Ah. All right, thank you. Does Louis get that one?
Yeah.
All right, 45 minus X. I knew it was there. I just didn't do it, I guess. Maybe my pen malfunctioned. We'll say
I
that.
think we should give it to Cyrus.
All right. I think Cyro has plenty, probably. We'll give it to Louis. All right. So then find the marginal revenue. Cyro got 101 on her first test. She's probably fine. She's blushing. All right, marginal revenue. So R prime. So it's going to be 9 minus 2/5 X. So I took the derivative of the revenue. And then profit. Profit was revenue. What's the equation? Profit equals revenue minus cost. So our revenue was 9X minus 1/5 X squared. And our cost was the 1/4 X squared plus 3X plus 67, the original. So when we simplify, we get negative 9 over 20 X squared. Let's see, plus 6X minus 67. Do you guys know how I did the 9 over 20 so fast? Were you guys like, wow, Mrs. Cox, you're so good at adding fractions. Do you guys remember that I taught you this? 1 times 4 is 4, 5 times 1 is 5. Add them together, divide by their product of the denominators. All right, and the last thing is marginal profit. So the marginal profit, P prime, is going to be negative 9 over 10, X plus 6. So negative 9 over 20 times 2, right? And then X. So I took the derivative here. You got it? All right, so I could ask lots of questions. I should say, what's the marginal profit for creating 100 items, right? What's the marginal profit for creating 2 items, and so on. Like you could find all of those different things by plugging in the numbers. Okay, so we'll do one more example when you guys get back. So go ahead and go on your break.
Hold on. I bet using money on
Example. So it says, suppose that C of x equals 0.2x squared plus 2x plus 4,000 is the total cost in dollars for a company to produce X units of a certain product. So it says compute the marginal cost at 100 and compare this to the actual cost of producing the 100th unit. So these are kind of strange questions. So if you're finding the marginal cost, we know that we're going to take the derivative. So our derivative of 0.02x squared is going to be 0.04x, and then we're going to have plus 2. And then we quickly plug in 100. So I have 0.04 times 100 plus 2. So we get 6. So what does that mean? It means around when you're producing the 100th item, then your cost per item ends up being around $6 per unit, okay? So you would want to sell it for more than $6. All right, so the actual cost of producing the 100th unit, that's a little bit strange. Anybody have any ideas on the actual cost of producing the 100th? It has to do with the total cost equation, like the C of x equation. Most people think that you just plug in 100. Okay, but that's the total cost of producing 0 through 100 units. So what about the 99? It involves 99, so it's actually going to be C of 100 minus C of 99. So you're going to find one of them, and then you're going to subtract out the 99 one. So I am going to go ahead and put these in for my table so I can find them quickly. I love the table function, if you guys didn't notice. Find lots of points all at once. So the cost of producing 100 items is $4,400, and the cost of producing 99 items is $4,394.02. So we end up getting $5.98. Okay. So which one was faster and easier to do by hand?
the marginal.
The first one, right? So that's why we use our marginal cost. It's just faster, okay? So you can do spreadsheets and so on to find the actual cost of reducing the 100th unit, but it's just faster to use something that's 1 degree less, okay? Derivative's always 1 degree less. So, all right, so find the production level that minimizes the average cost. So it says, what does the minimum of a graph look like? How is that related to slope? So the minimum of any graph, what's happening right here? What's the slope? It's 0, right? So we're going to find our average cost, and then we're going to find its derivative and set it equal to 0. So there's a lot going on here. So the average cost is our C bar. So we're going to take our total cost, and we're going to divide by x. Right, that's what C bar was, divide by the total number. So we get 0.02x plus 2 plus 4,000 over x, which I'm going to write as 4,000x to the negative 1, because I want to take the derivative of it quickly. So C bar prime, isn't it fun saying all these math things? C bar prime is going to be 0.02 minus 4,000 x to the negative 2. And we said we wanted when our slope is equal to 0. So we're going to set that equal to 0. So now I'm going to rewrite it as 4,000 over x squared. So I have 0.02 minus 4,000 over x squared. So I'm going to add the 4,000 over x squared over. I'm going to divide or multiply the x squared over, so 0.02 x squared. And then divide by 0.02. So 4,000 divided by 0.02, and then take the square root of my answer, and I get x equals 447.216. So what is the level that minimizes the average cost? We want to minimize our cost function, our average cost, so we want how many units? Yeah. 0 units. Is it smaller? I don't know. So it's going to be, we think that it's going to be 447 units. Now Grant does bring up a point. He said it's 0, right? You don't have a cost if you don't produce any units. Well, what if you own a factory? And what if you hire all these people to come into work that day? And then you have this big machine that you paid money for, and then you produce 0 items. That would not be good, right?
Is it worth that going?
Yeah, when people go on strike and so on, that's not good. So really, we should eventually, and we'll talk about this, when we talk about maximum versus minimum, we'll compare these different things. So you could try like, well, what happens when I plug in 500 units to here versus plugging in like 0 units? You kind of want to try things on both sides. So you would try like 500 and you try 0 and then see which one gives you. 0 wouldn't work actually because it's undefined there, but you could try like 1. And then you would want to make sure that that is the minimum amount. And I think it is.
So when it ever says minimize the average cost, which basically means equals 0.
Yeah, but that's also what you would do for maximize the average cost. So you really would kind of have to compare. So if I plugged in 0 into my C bar function, or not 0, let's say I plug in 1, I get 0.02 plus 2 plus 4,000 times 1 to the negative 1 is 1. So I'd get $4,002 and, or 4,002 and 2 cents, like that. And then if I plug in like 500, let's say, 0.02 times 500 plus 2 plus 4,000 times 500 to the negative 1. So you get 20. And then if you plug in 447, what was that, 20? Yeah. Yeah. What's up?
No, I'm curious.
And then this one's 1989. So creating no items, or in that case, one item that we did, cost you like $4,000, right? So that's not good because you've already paid money for this, for various things in the factory or whatever. And if you create 500 items, you're at like $20, but this is kind of the sweet spot. You want it to be as small as possible per item, okay? Does it make sense? You get it? Alrighty.
So is your answer